All right, so let's take a look at what happened. One of the cool things about the system here is, now that we have just done it, we can actually get the quiz statistics right away, which is kind of fun. And we can also go over the answers. So let's do that. So here are the quiz statistics. The high score was 100%. The low score was 37%. And here you can see people are up here, a bunch of people here. Although quite a, if you're down in the region where you are, let me get back to this draw. If you're like the 6, 5, 4, 3, you definitely want to think about your studying for the class and keeping up. I mean, I know life is kind of crazy right now, but you still, at the end of the day, there are some core concepts you really need to be able to demonstrate mastery of to pass the class. So make sure if try to figure out what's going on. And again, we're like over halfway through the semester, so and kind of getting into a rhythm with this new way of life on remote instruction. So if there still need to be adjustments made, we can do that, but definitely you don't want to just keep doing what you're doing and just assume it'll get better, because often that's a bad way to approach it. So let's continue and look at what we got here. Let me clear that out here. Whoop. Oh, let me get rid of that annotation. Okay. So cardiac output. We had 2/3 of the people. This is kind of wild to actually be able to see this, actually. It's kind of fun. 2/3 of the people got this one correct. Cardiac output, we talked about. It's really straightforward. I've drawn it on the board again and again. Stroke volume times heart rate. It's like in the definition of it, heart rate. It's liters per minute coming out of either ventricle, but it's really at the core of the way you should be thinking about cardiac output. It is the stroke volume times the heart rate. Blood volume affects blood pressure, but it's not really directly anything about cardiac output. Pulse wave velocity has nothing to do with it. Diameter of the blood vessels, that does resistance, not cardiac output. So again, if you're one of the 1/3 of the class that got this wrong, you really need to get to your first principles of cardiovascular physiology. Those equations, blood pressure, cardiac output and resistance, and then cardiac output with stroke volume times heart rate. You really need, those are like the first principles that everything else comes from. So you really need to make sure you feel those make sense. Oh my God, half the people got this one wrong. During ventricular filling diastole. So if the ventricles are filling, that means the blood is coming down, returning in the veins, the vena cava and the pulmonary veins, back, pouring through the atria, filling into the ventricles. So you're not going to be able to fill into the ventricles if the AV valves are closed. In order to have blood pouring into the ventricles to fill them, we have to have the AV valves open. So having AV valves closed couldn't work at all. The blood would just hit a wall trying to get into the ventricle. And then diastole is when the semilunar valves are closed. That's keeping the diastolic pressure from pushing back up into the ventricles when they're relaxed. So the answer for this one is going to be AV valves are open so the blood can be flowing in to fill. The semilunar valves are closed because that's keeping the diastolic pressure in the arteries from backflowing back up into the ventricles. So this should make sense to you as well if you really think about it like that. All right, arterial vasodilation. All right, this we've been beating this horse into the ground since like we introduced the idea of cardiovascular system. Again, at the core of so much of cardiovascular physiology is blood vessels constrict, more resistance. They dilate, less resistance. It should also feel kind of intuitive, right? If you have a bigger pipe, it's going to be easier to get the flow. If you make the pipe small, it's going to be more resistance for flow. So you can also think about it just intuitively, right? Even just like blowing air out of your mouth, harder, easier. Arterial vasoconstriction in the major arteries. You know, again, this takes this part to the next level. Arterial vasoconstriction increases resistance. And then we know blood pressure is just cardiac output times resistance. So if resistance goes up, cardiac output goes up. Again, adjusting blood pressure, one of the main short-term controls is by constricting or relaxing arteries. And that's gonna bring your, if you constrict, the blood pressure goes up, relax, it goes down. Again, this is at the core of all the stuff we've been talking about today in lecture. P wave. I think I actually had like a bunch of different versions of this. P wave, that's the beginning. Yeah, so most people got it. You know, atrial depolarization. What if it had said T wave?
Ventricular repolarization.
Ventricular repolarization. If it was a QRS complex?
Ventricular depolarization.
Yeah, so I think different people got slightly different versions of this depending on which. I think I had to just spit out random questions at you, but you know, with different waves. Valves. Okay, most people got this. Only a couple of people missed. They don't contract to propel the blood. They keep the blood from backflowing as it goes under pressure. When the ventricles are under pressure, it makes sure the AV valves make sure it doesn't go back up into the atria. When the ventricles are relaxed, the semilunar valves make sure that the blood doesn't backflow from the major arteries. This you just got to know. The sinoatrial node, the pacemaker. You know, AV node is triggered by the SA node. The SA node has that little interventricular pathway, or that internodal pathway. SA node starts the whole thing, 0.1 second delay, then talks to the AV node, which then triggers the ventricles to do their thing. But the SA, sinoatrial node, is the main dude who's doing it. Blood pressure, always greater in systemic circulation, right? 3 to 5 times because there's so much more resistance. Some of the other questions said cardiac output. What if the answer here said cardiac? What if the question was cardiac output? What would the right answer be?
It would be equal.
It'd be equal. Cardiac output is the same. It's equal in both circuits, but blood pressure is much greater in the systemic circuit. And then there's this one. Blood pressure affected by overall blood volume. It's kind of crazy for me that 25% of the people miss this after we've just been like, blood volume is a major thing to control your blood pressure. I mean, so you really do want to kind of, we introduced the idea last class, and it was like at the core of the long-term control of the Iranian angiotensin mechanism right now. So again, you really want to work with these concepts. Directly proportional to cardiac output. Again, BP equals CO times R, so directly proportional. Directly proportional to peripheral resistance. Only half the people got this. I mean, I keep writing on the board. I mean, I don't know what, I mean, the resistance is one of the key things that is affecting your blood pressure. That's why vasodilation and vasoconstriction affects your blood pressure. So if you got this wrong, and I put these up, I have it so I think by tomorrow morning, actually, since I think everybody took it. So actually, after I'm done with this, I'll just go in and change it so you can see your answer. I want you to be able to go back and see your answer, and kind of, if you got this wrong, you need to figure out why you got it wrong and make sure for the main exam that you understand this. Because again, these are all these core concepts I keep kind of reiterating. Here again, I just mentioned this directly in the lecture just now. And again, we had, quarter of the people got this wrong here. Drugs that act as beta adrenergic agonists, beta blockers, decrease contractile strength of the muscle, slow the heart rate. Again, that's gonna lower cardiac output, which lowers blood pressure, but decrease cardiac output. I was just trying to say that really, really explicitly. So if it didn't quite click when I was first doing it, kind of go back and make sure you kind of understand why that makes sense and what's going on with these drugs. These are the other versions of the questions. Here they are. During ventricular ejection, again, we ended up getting 30% of the people getting this wrong. Ventricular ejection, means that's when the AV valves are closed, and you are therefore not going to be spewing blood back up into the atria. But the semilunar valves have to be open, or you couldn't be doing ejection, right? You're spewing blood out of the ventricles into the main arteries. So these semilunar valves got to be open. They're closed. The beginning of systole during that isovolumetric contraction, then they're both closed. But during ejection, I was very clear to make sure that said ejection, so you knew the blood is splooshing out into the arteries. Again, these are just the ones we talked about. T wave is the ventricular repolarization. Cardiac output. Holy crapola. So we had 60% of the people get this wrong. Cardiac output, it's equal on both sides of the circulation. That's really important to understand. And again, what's the condition if it's imbalanced and you start not having the heart being able to sustain an equal flow on both sides? There's a disease state.
Congestive heart failure?
That was a congestive heart failure. And you build up like back pressure on one side or the other. But yeah, both sides have to have equal flow because each side pushes the blood out to the opposite side. So if they're not balanced, then they start backing each, overall, there's way more blood on the systemic side, way more thousands of kilometers of blood vessels on the systemic side, a lot higher pressure on the systemic side, but the actual liters per minute pushed out either ventricle is always equal. Arterial vasoconstriction, should be increased resistance to flow. Yeah, so are there any questions about any of these? I can actually, let me go into this thing right now. Let me edit it. I'm going to say, let the students see their correct answers. I need to say the time. What's the time? It's like 10. So you can go back in now and you can see your correct answers. You know, again, these quizzes, normally I let you keep the quizzes. I want you to study from these, and, you know, missing points on a quiz is not it's not going to affect your overall grade. And it's a good way for you to get information about the things you need to understand more deeply by the time we get to the main exams. So, and cute little cat with the stethoscope. Any questions about this? Nope. All right, let's go shift gears to the big exam 2, which I finally finished grading in the wee hours of the morning. And we can take a look at it here. Quiz statistics. Yeah, we got the classic bimodal distribution on this one. We got a whole lot of people got A's, including a couple of people over 100%. I figured this out. It's like actually like half the class got A's. Like half the class got 90 and above. But then, you know, there was an appreciable number of people down getting like with the C's, and a few people with literally getting only half of them correct. So, you know, if you're up here, that's a good sign. If you're down here, you know, it means that you're holding it together, but you probably want to, you know, figure out what you're doing and you're studying and how to kind of bring that back up. If you're down here, I'll probably reach out to you at some point. We have to kind of figure out what's going on, because, you know, that's very concerning, especially at this point in the semester, to still hitting a place. Yeah, normally today would be, you know, writing research papers, which we're obviously not doing our actual experiment, but we are still going to do a research paper on something where you're going to look up information about what do people know about some topic that you want to understand more about. And you all did that green tea assignment back when we were all still, before any of this all got weird. And the whole point of that green tea assignment was to get used to searching the literature, and also get used to then, once you search the literature, how do you then use that information and write stuff and support what you're writing with those research articles? What's the proper format to use that information? And normally I would have gotten back to you long before now and given you some feedback, but instead I'm going to give it to you now before you're actually hopefully getting too deep into your big research project. So remember your research project. Things that, you know, so you need to definitely use peer-reviewed research to support your points. Proper references using the Harvard referencing system. There are different ways. There's APA, there's MLA. I find that this is the one that's used in most of the scientific papers that I come across, so it's what we're using. Use your own words rather than direct quotes. In other kinds of fields or research, often people do extended quotes from somebody else. In science, usually you kind of paraphrase what somebody's results were. You don't actually lift the sentence out of their paper. I'll show you some examples of where people did that. Other things, don't cherry pick. Like if you are trying to decide whether or not research supports something or not, don't just find the articles that say what you want them to say and ignore anyone that actually contradicts that. And in reality, most of the time there are going to be conflicting reports or ambivalent results. And that's important to make sure that that is clear for your reader to know, that it's not, if there is some ambivalence about some basic conclusions, that should be in there. Or if in general it's, the preponderance of evidence supports it, that's also good to know. But then you trust it rather than just, oh, this person found this one article that seems to say what they want to believe. What do they call it? Confirmation bias, right? If you kind of believe that's the way it is, and then you find one thing that supports that, you just like, oh, that proves that I'm right. But that's not the way the real science works. You want to make sure you kind of look at the broader range of results. And I'll say this one more time. I said this earlier. I've noticed it in some science. Doesn't like definitively prove. Oh, dang it. Instead, it supports. So science does not tell you definitively this is the truth. So stay away from using the word prove. It definitely is one of my pet peeves. If like studies prove that such and such, studies support, the data supports. One of the things that's a little sad that you won't get to see by doing your own research project is the reality of doing science is way messier than you would wish it would be. And you do your best to see what the data has to say, but you don't want to say prove. So all this being said, let's go look at some people's names have been protected. No, names have been gotten rid of to protect the innocent. Or no, to protect the guilty, I guess, in this case. All right, let me share. All right, so I'm starting with one here that actually is, pretty good. So they're kind of writing stuff. Green tea has been, you don't have to be this fancy with your, you should be, make sure you have good English. Sometimes people turn in things where the sentences are completely mangled and the grammar is totally messed up. So it should be good English, but it doesn't have to be, bandied about as the darling, so it's up to, it doesn't, don't, you're not getting graded on style-y, but you are being graded on clarity. So it should be clear. But then, so this person claims continue, so they're saying something and then there's a reference. Then there's been a large review of nervous studies that suggests there are probable health benefits in the flavonoids in tea, Zing et al. So this, whenever you say something that's not just common knowledge, you have to say, like, according to where? How do I know this? I'm not gonna, you can't just say large review and just leave it there. You have to tell me, give me some way to go find that review so I can convince myself. Scientists are notoriously, distrustful is the wrong word, but really want to see it for themselves. Yeah, you can tell me that, but I want to be able to double check and make sure I convince myself that I come to the same conclusion that you do. So, 28-day, blah, blah, blah. And notice that they're talking about the study, maybe they're talking about a study, and then there's the reference to the actual paper that describes the study, but they don't quote anything out of the paper. They're using their own words, kind of paraphrasing the results. So just kind of putting that out there. That's, this is continuing. And then here are the references. And again, the references are done well here. Oh, actually not totally. There's a mistake here that you're going to need to talk about. Where's my, oh, wait, I don't, there it is. So you should not have an et al. In your final references. When you have more than one author, it's good to have et al. In your inline references. So here, though, this should have all the authors when you have your final list of references at the end. So this should not be et al. But the rest of this is good. It has the title, it has the journal, and then it has the volumes and pages and things like that. Again, I showed you how you could go into Google Scholar and it will actually help you generate what this should look like. Also, in the appendix of your lab manual, I have an appendix, a thing about using Harvard referencing. So.
What if you grab something from our textbook? Can you do that?
No, that really doesn't count. That would be like a tertiary reference. You need to be going to primary references, peer-reviewed research.
Okay, but if you don't count it as one of your sources, should you, if you...
Oh, then you can use something there.
And
yeah,
then
and there's a way of if you go into that appendix, it will say how you reference that as well.
Okay.
But in general, that should not be used, as a main way to support your points. So here, this one here, this idea, research will prove, no prove, don't use prove. Also, this is using direct quotes. And again, in other kinds of research, people use direct quotes a lot. In this kind of research, it's a style thing, but it's just not how people do it. So don't use direct. Here, this person is saying, quote, tea polyphenols were reported to reduce Nakachi K et al. So it's good that they have this information and they have a reference, but they should just put it in their own words. Also, the reference here, this Nakachi et al., it should actually have the year on there. So they kind of forgot to put the year. So this should also, Nakachi et al. Is good, but it should also have a year. Similar here. Again, the content is good. They're doing the right thing in terms of bringing in important points, giving us the reference of where that comes from. But just the basic style that people use is not using direct quotes. So avoid direct quotes. Again, the only time you use direct quotes in this kind of writing is like if somebody has said something and there's got some kind of historical context or something, like if I'm talking about the history of physiology, and then I would say, and then like, I think I did it in class, like, in the 18 such and such, Claude Bernard said, le constant c'est de milieu intérieur, like whatever. He's got like this famous thing that he said about homeostasis that kind of set the stage for the rest of biology. So then that you can put that in quotes. But in general, for this kind of thing, no quotes. Let's see. This assignment said minimum 4 references, and they only have 3 here. That's another thing. Read the details. Make sure you kind of stick to the details. And this has another thing of proven. Again, you can say support. You use the word support. Yeah, I mean, that's one of the things. Science does not prove. So this one here, this person kind of used their references kind of like a bibliography, like from a book report, but there's no actual inline references in the actual text, right? So that's not okay. Whenever you have a statement, you have to actually have the author and year in parentheses that support that statement. In general, also, you don't have to, you don't talk about, a study performed at such and such. I don't care where the study was performed. I just care what are the important points. So, I don't care if it was in Iran or in China or in where else, I don't know. But no inline references, that's not okay. And then these references, like, this is not a reference. This is some URL, which is probably going to disappear even. You need to use I mentioned it that like in class, and it's that Harvard referencing scheme. This has no name of the article, actually no name of, yes, and yes, so this is not okay. This doesn't even have authors or anything. So make sure you know how to do proper citations from your appendix. And again, like I said, if you can Google Harvard referencing as well, or you can also use it from your, in Google Scholar, it's good at doing that as well. Let's continue going on. Again, problems with this, they just don't have the year. Overall, this is looking good, right? You know, others have found that EEG, CG can be used to modify glucose metabolism for the better in diabetics. Tsunuki et al., but it just needs a year. In fact, this is I can add another point here, which is actually going to be useful. So again, missing the year, which is not good, but giving specifics about what the study found, that is good. Some people were really vague. They would studies have shown that, green tea affects such and such or whatever, but how, what, give me some details. You're just leaving me hanging here. So you want to make sure you don't have to get into crazy detail, but enough detail that you have some sense of what's the core story that they said. So this person here is really good at, adding in enough detail that I have a good sense of what exactly did they look at, not just, oh, it's good for you, but that's so vague. How, in what way, what evidence did they find that it's actually good for you? So just kind of putting that out there, a little bit of detail and not leaving it too vague is a good thing. Oh, here I was trying to, so it's that same person who had the, they didn't have the years on their inline references, but these look great, right? So this, for the ones with multiple authors, all the authors are there, the year, the title of the article, the journal, the volume, and the pages. So this person really followed through in getting their references in the perfect format. So this one, a few people did this, which another cautionary tale. Kind of summarizing a bunch of different articles, but never really integrating and telling me the story. How does it all fit together? What are your conclusions based upon all these different studies, right? Because often the studies are conflicting even. And so it would be nice to see, all right, after looking at all this, what are your conclusions and why is that where you've ended up? So, integrate everything in order to kind of tell your story. And again, don't leave, for the most part, this person was doing their references okay, but here they kind of dropped the ball and it's kind of just, so I think it's some author, but just kind of hanging in space. Continuing. Yeah, so like I said, should not just summarize studies. Yeah, here, this person got too detailed. The inline references should just be the author and the year. And then here I don't quite understand why did they capitalize coronary heart disease and put no spaces in between? Or, it's just think about your basic grammar in English when you're doing this kind of stuff. Let's see. So this, I don't know if it shows up as easy for you. I find this happens a lot when people cut and paste stuff. You end up getting its stuff in all these different fonts, which is really disconcerting. And it just looks kind of, it's aesthetically unpleasing. So even, cutting and pasting a reference, especially like out of Google Scholar, that is fine. Cutting and pasting other stuff, like content for what you're writing, that's totally not fine. But if you're cutting and pasting some pre-formatted reference, I could see that happening. But at least format it all so it all matches itself and doesn't all, it just looks, I don't know. It looks sloppy. I mean, it's crazy. Some people, when they start cutting and pasting and doing kind of more hardcore cheating, maybe it could be the people who cheat often just aren't thinking that much in the big picture anyway. And that's why they are cheating instead of doing their own work. But I've gotten papers where just whole sections, it keeps alternating from one font or even color to the next. And it's like, okay, dudes, come on. It's so clear that you didn't just sit down and type this up. All right, what else? Oh, so TMI, too much information. This was a thing that happened in a number of these papers. In an article written by the Biomedical Sciences Department of Oakland University, William Beaumont School of Medical, and the Biomed Research International Journal, they stated, quote, it's like, oh my God, I don't care. I can find out that detail if I go to the paper. What I care is, oh look, researchers have found green tea has the ability to eradicate infectious agents and actually prevent infections. Ragart 2018, that would be great. So just what is the core finding? Give me the reference so then I can get the details if I want. But I don't need all that other information. It just kind of, it messes with the flow. Again, this person still has some issues around using lots of direct quotes, which you don't need to do all these direct quotes. You just use your own words. You should not have years just on their own. There should always be author and then a year. That way you can go to the list of references and you can see what the reference is. You don't need, in fact, don't put the URL, this web link here, because web links are notoriously ephemeral. They disappear. They're there, and if you've ever gone back in your bookmarks list and go find old bookmarks that you've had from a while ago, it's freaking like 3/4, 80% are going to be broken. The web is really, it's like quicksand. Web links are not that interesting. Actual authors, years, journal names, journal volumes, that's what we care about. Again, here, this is kind of the opposite of the other person. A little while ago, we had somebody who was using et al. In their list of references when they should have been using the full name. But here, if you're in the body of your paper, this would just be Kapustaskin et al. 2020. So if you have a bunch of authors, you just say the first author, et al. I think it's short for et alia, means like and others, and I think Latin probably. So et al. Is your friend, so you don't have to type out all the names of the authors. The typical thing is one author, you put their name. Two authors, you usually put both their name. Once you're more than two authors, you usually just do first name et al. Right? I'm just looking at the, I mean, from the top of my screen, It's Prescott. It would be like Prescott 2018 or Prescott Knudsen 2020. But if it was Prescott Knudsen and Premaboot, I would just say Prescott et al. 2020 or something. So let us continue with our so this one I put in here because a lot of these things I'm giving you examples of what not to do, but I figure, make sure you have examples of what to do. Again, something like this. This is really nice. It's kind of talking about stuff whenever they have, it's been linked to beneficial results. There's, the other research folks examine one polyphenol epigallocatechin, 3-O-gallate, ECG, blah, 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 is found to prevent neurodegenerative amyloidosis. How do we know? Seiki et al. 2018. And then again, I can go into Seiki et al. 2018 and look up the details of that if I want. Oh my God, there is Seiki and the rest of the crew 2018. Here's the actual article and I can look it up there. So just kind of giving you a model of what things look like when they're done properly. It's kind of, they're creating a story, they're supporting it with different references. The references are properly cited and then properly listed in the end in this list of references. So your research projects are going to be like this on steroids, kind of nice and pretty, well structured, well supported, well formatted. But this is just, again, this is kind of just this TMI, too much information. In the article, anti-inflammatory action of green tea, I don't care about the title. I can find the title if I go into the reference. You can just say, one study showed such and such, Oshishu et al., whatever year. So just, and again, if at any point you're having questions about how to do this, just ask. I am happy to give you information or give you feedback. This one, be careful about just how you write things. Like, supposedly there is evidence from a primary reference, Wang et al. It's like, either there is or there's not evidence, so I'm not quite sure why there's supposedly. So kind of read it through and see, does it make sense? Clear that and continue. I think we're almost done with these. Again, these almost look good, except, some of them are missing the volume. And like this first one here doesn't have the volume in the pages. The second one does, but it shouldn't be et al. Again, none of these should be et al. And these are this one is got a year and pages, but it's missing the volume. So when you're doing these references, there is a right and a wrong way. So please, ultimately, you will get off. You'll get some points off on formatting if you don't do this properly. I will come up. I realize you don't have a rubric yet. I have a beautiful rubric for the research project, but I have to create a rubric for your, I should say, I have a beautiful rubric for the independent research thing, but I don't have a rubric for this yet. So that's another thing on my to-do list. Like, hopefully before this week is out, I will have a rubric. So you will also have something to shoot for in terms of how is this actually being graded and what do I need to be paying attention to? I've just talked a bunch and showed a bunch of examples. Does this give you a better idea of how you take literature from the reference? references from the literature and kind of integrate them into a narrative that is supported with peer-reviewed research to kind of tell your story. Are there any questions about any of this? Peter, I can't hear you, Peter. Or now
Now can you hear me?
yeah.
Okay. So do you only want us to use peer-reviewed references, or do you want us to like look at primary references too?
Well, the primary references are the peer-reviewed ones.
Okay.
So the things that I do not want you to use would be like, websites and things
Right.
like that.
Uh-huh.
But in general, primary references are peer-reviewed. There are some journals that are not totally peer-reviewed, but most of the major journals are peer-reviewed.
Okay.
And also, I've mentioned before, but I'll mention again, if there are papers, for the most part, just from reading the abstracts, you will have enough information about what the study was about to give you what you need. But if you would like the full text, a PDF of any article you come across, just let me know. I can get full access. Again, I have connections through Berkeley to download PDFs of whatever. So if you click on things, sometimes they'll say like, well, it'll cost you $30 if you want a PDF of this article. So don't do that. If there is an article, particularly if there's like a review article or something that you think would be really nice for you to have in your hands to read to help you with your paper, just, look for it first. You can do Google Scholar. Sometimes Google Scholar actually crawls the web and finds somebody that's uploaded the PDF someplace and the publishers don't see it yet. And so it's still there. Or ask me and I'm happy to send you PDFs of whatever.
Could you remind me of the due date?
I think it's near the end. Let's go. I'm going to go into my, give me a second here. Does it have a due date yet?
You haven't discussed it yet, so.
Yeah, so good question. The due date. So typically the research presentations are on May 6th. All right, so I will say this then. We'll do this officially. So there's two things. On May 6th, you should have the write-up done, which you're going to upload, probably just upload to turn it in. And you will also, during this process we talked about, there's going to be a PowerPoint presentation that basically summarizes the important points and supporting references of your whole write-up. It's going to be a PowerPoint that you will present to the class. And so we will have people taking turns and presenting things as well as part of their PowerPoint. And the PowerPoints will be pretty quick. So both your PowerPoint and your written report should both be ready to go by May 6th.
Is there a page length you want for the report?
I don't know, I'm not sure exactly how many pages.
Okay.
Enough to cover your material well.
Okay.
Yeah, I can think about it more. I don't know if I have a particular, I think I put some like minimal number of references in the original assignment. Did people remember what the original assignment that I put up on the web was? I'm going to it right now.
Pretty sure it was 8 references, if I recall, as a minimum.
Okay, yeah, and again, that is there just as a minimum. I mean, you probably have more than that even, but just to make sure that you don't drop the ball on it. I'll think more about some of the details. Again, a lot of this online has been like as needed. So like I got the basic assignment thought up and introduced. And so the second part is going to be coming up with the rubric and the other details about it. So how about I'll say to be continued. So there will be a little, I will give you a little more direction before the weekend is out.
So should we come to your office hours to discuss one of our proposals, or just kind of pick one and get going? Or
So I am going to look at those. That's another thing I will do either tonight or tomorrow is just go through those and double check them.
okay.
And then give you feedback and either tell you just go ahead or we can talk about it.
Okay.
Yeah, so so I will do that. I've just started doing, kind of starting to catch up on some of this other stuff as well. Other questions, comments?
I had a question about the Sen gauge.
Uh-huh.
There's like the assignments, and some of them are marked like goes towards your grade. Are those the ones that you want us to complete, or it's just kind of at our own?
They're just kind of at your own
Okay.
pace. Yeah.
For references, I've been looking at like guides for the Harvard reference style, and a lot of them say varying information, and I'm wondering if there's like a certain reference you want us to go by, or
I'm in the I think it's appendix, is it B or C in your lab notebook?
there is that, yeah, but just like going into more detail.
It should all be pretty similar. If you have particular questions, ask me. But the basic system is, for at least for primary references is, author, year, title, journal, volume, page. So, but yeah, you can if you have any questions, just email me and I'll try to clarify. Any other comments or questions? So next class, we'll get to hang out with Mr. Blood Drop. And we'll spend some time learning more about blood. The lab will look at how we look at different properties of blood. And also we'll be starting the respiratory system in lecture beyond blood. But until then, little Bernice the Blood Drop says, See ya.